The sine law does not allow you to solve all acute triangles. For example, in this situation where you have all sides, or this situation where you have two sides and a contained angle. You don't have that opposite pair angle combination, so you can't use the sine law. So that means that we need another comparison between the side lengths and angles of a non-right angled triangle to allow us to solve for the missing pieces. So we do have something called the cosine law, which we have here. You can also write it with the different side lengths in place of A on the left-hand side, depending which side you're solving for. The B and the B, or A and the A, they always fill in the bookends of your equation. We can also write an expression for C here. I actually should have C's here. And then this last one is we're looking for side C, so we've got a squared plus b squared minus 2ab, and then cosine C. We can also rearrange that to solve for an angle. A squared minus b squared minus c squared is equal to minus 2bc cosine angle A. Then we're going to divide both sides by minus 2bc. And then I'm going to get that cosine A is equal to a squared minus b squared minus c squared, all over minus 2bc. The last thing that I'm going to do is take that minus sign up into the numerator here, so that I'm going to get b squared plus c squared minus a squared over 2bc. So we really have two versions of the cosine law. One is easier to find a side, which is this format here. C squared equals a squared plus b squared minus 2ab cosine C. And then to find an angle, we have this formula here. So cosine C is going to be a squared plus b squared minus c squared, all over 2ab. So you can use either one. You can only use the first one and always rearrange to find the angle that you're looking for. So let's look at a couple of examples of how to apply the cosine law. In the first one here, we're going to find p to 1 decimal place using the information that we're given here. So we know two sides and a contained angle, so we're going to be able to use the cosine law. What we want to do is set up our triangle so that we're solving for side length p. So p squared is equal to q squared plus r squared, my other two sides set up like the Pythagorean theorem. And then I have this extra sort of correction factor on here because it's not a right angled triangle. And then cosine p, making sure the variable that I'm solving for forms my bookends of the equation. At this point here, I'm going to substitute in what I know. So I've got 4 squared plus 3 squared minus 2 times 4 times 3 cosine 80 degrees. And then this is something that I can put all into my calculator and evaluate. And I should get about 4.6 meters as my value for p. Let's look at another example here where I'm going to solve a triangle. So I've got triangle ABC. My side length A is 7 centimeters, side length B is 9 centimeters, and side length C is 10 centimeters, and I need to find the 3 missing angles. So for the first round, I'm going to use the cosine law to find one of my angles, and I'm going to start off by finding angle A. So I'm going to set up my cosine law to find that angle. Making sure that I've got my A's at the beginning and end, and then I've got my other two sides in the remaining spots of the formula. The next thing that I'm going to do is substitute in what I know. So A, B, and C. So I've got b squared plus c squared minus a squared all over 2 times bc. And I'm going to take the cosine inverse of that expression to give me the value of my angle A. When I do that all on my calculator, I should get 43 degrees. That tells me what one of my angles are. Now that I've used the cosine law to find that angle, the next thing that I'm going to do is I'm going to use the sine law to find one of my other angles. So the next one I'm going to find is sine C. I can use the sine law because I now have a pair of an opposite side and angle. So I know that sine C over C is going to be equal to sine A over A. I can rearrange a little bit here. I know that sine C is going to be C sine A over A. And then I'm going to end up taking the sine inverse here. Sine inverse of C sine A, that's the angle that I solved for at the beginning, over side length A is going to give me my value for C. When you do that in your calculator, you should get 77 degrees. Now my missing angle, angle B, I can just use the fact that all three angles in a triangle add up to 180, giving me B equals 60 degrees. Let's look at one more of an application problem. Here we're asked to find the area of triangle DEF accurate to one decimal place. Normally you'd find the perpendicular height and you would multiply the base times the height divided by 2. There is another formula for the area which is also on your formula book. The area of this triangle is going to be equal to 1/2 D times E sine of the contained angle. So the area of the triangle is really any two sides and their enclosed angle. So what we can do here is I'm going to choose to find angle F and then find the area. You could do the same thing by finding angle D or angle E. So let's go about finding angle F by setting up our cosine law. So we're starting off with cosine F. On the right hand side we've got our other two sides with F as our bookend on the numerator, and then 2 times D times E. Substituting in what I know, I've got 7 squared plus 6 squared minus 5 squared, because my sides are D, E, and F in the triangle, all over 2 times D times E here. Evaluating that on your calculator should give you 44 degrees as your angle for F. And now I have enough information to be able to find my area of the triangle. I can do 1/2 times D times E, and then sine of the angle between those two sides. Once I have all that information in, I can plug it in on my calculator and evaluate, giving me an area of 14.6